Now we're going to take what we know about parametric equations and put it into applications or word problems. So the first thing that you want to do is, first of all, you have to know the x and y equation format. So for the x, we're describing the horizontal movement. The y, we're describing the vertical movement. So vertically, we're going to be taking into account the initial height and gravity. So y's are going to be longer. For my x equation, it is just velocity times cosine of the angle that is happening times t, or time. Then I always remember y starts off similar, so 58, but this time we're doing sine because that is the vertical. Then we've got minus 16t squared, that's the gravity being taken into account, and then we're starting 5 feet above, so that's going to go with the y. That's my parametric equation. If you wanted to, you can plug those in, get some decimals, that's fine, or I usually just leave it. If we were to sketch that or graph that, we can do that on our graphing calculators. So what we just need to do is we need to change the mode. So we go to mode, and if you notice, I've already changed it to parametric, PAR, so we're going to do that. And then the cool thing is when we go to y equals to graph, I'm going to delete these. If you notice, I've got an x equals and a y equals, so it's already set up for us. 58 cosine of 41, close your parenthesis. And then we've got to put the t in there. So if you notice up here on the button, x, t, theta, n, if you hit that x button, it is now a t. And then I'll type in my y equation. Just do not forget the t's. That's usually what happens if it's not graphing accurately. And then hit graph. And you're going to have to do a lot of window adjustments most likely. But this should describe the path of that object. And it does. Let's see here. My y max is way too big, so I'm just going to put 50. And think realistically, if we're throwing a dart, probably not going to throw it higher than 50 feet. So that's a good way to kind of get your window set up. So this is the path of that dart. That would be when it hits the ground. This would be its maximum. The problem in parametric mode is if you do calculate, we can't just calculate intersections or max and mins. So we're going to do that by hand, but that just gives me the shape. If I want to find that maximum, it's the vertex, essentially, of this equation. So negative b over 2a is coming back into play. If I take my negative b, I'm going to have negative 58 sine of 41 over 2a. And then if I type that in, 58 sine of 41 times negative 1 divided by negative 32, I get 1.19. That's going to give me t. So that's when it's going to hit its maximum height. Then if I want to find the maximum height, I just have to plug that back in. Well, if I wanted to know the vertical distance, I'm going to use the y equation. So that's time, that's in seconds. And then I'm just going to plug it into my y equation, and I can do that right here. So 58 sine of 41 times 1.19. And then I usually add the 5. There's multiple ways that we can do this, but squared, and I end up getting 27.62, and that is the maximum height. You could also, on your graph, use the trace feature to kind of say, am I in the right ballpark? So if we're looking at my y's, we're at 27.56. It's just skipping over. But yeah, that is approximate. My time, 1.25. So yes, we are in the ballpark. That's a good way to check your work. When it hits the ground, so while we're on the graph, it's going to be somewhere about 2.5 seconds. You can see down here. But to do that, that's when y is equal to 0. So I'm going to plug everything else in. And then we've got to solve it for t. Well, we've got a quadratic. You either got to factor, complete the square, quadratic equation. This is not one I would want to factor. It's probably not factorable, to be honest with you. So we're just going to do the quadratic equation. Whoops. 58 sine of 41 is going to give me 38.05. That's my b value. So now I can say negative b plus or minus the square root of b squared minus 4ac over 2a. So now we're just going to plug this in. Whoops. Let's start over. 0.05 squared minus 4 AC, square root that. That gives me negative 38.05 plus or minus 42 over, and technically you have two equations, but if I know I'm dividing by a negative, and this is solving for when time, I need to find a positive time, so I'm not going to do negative 38 plus 42 because that's going to give me about 4 divided by a negative, not going to happen. So I'm going to do negative 38 minus 42 divided by negative 32, and that tells me exactly 2.503 seconds is when it will hit the ground. You could do more with that. If you wanted to know how far it would be, you would just plug that into T for the X equation. So these parametric equations, you just have to think about what do I have, what do I need, is it horizontal or is it vertical, and plug it in correctly.